Okay, so this is the enlargement question. We have the centre of enlargement 0, 3. Remember, 0 is the x value and 3 is the height, the y value. Most common error was to put it on 3, 0, not 0, 3. The way I do these questions is I work out how to get from the centre of enlargement to a corner of the shape. Here we've gone 2 down, 2 across. And because it's scale factor 2, I know the new shape is going to be twice as far away from the centre of enlargement. So I'm going to do this and again, because it's twice as far away. This is the corner. And once we've got one corner, we can just draw on the shape because we know it's twice as big. So where the base was 2, it's now 4. Where the height was 4, it's now 8. You can check this by doing a projection line, and it should all link up. Okay, how do we get from B to A? Well, from B to A, it's an enlargement, it's changed size. The scale factor, it's got smaller, so it's scale factor half. It's half as big. And the centre of enlargement is still the same because the projection lines would still be the same. They would still all go to the point 0, 3. Moving on. Okay, in this question, common errors were to misread the question and think it was a time sign. You have a calculator, so I'm surprised that people just didn't type this in their calculator and check the answer. Okay. What you can do, if you wanted to, is you could write out the number in ordinary form, so a 5 with 12 zeros and then a 9 with 12 zeros. Add them up. Every column will be 0 apart from the last column, which gives you 14. So it's 14 with 12 zeros. And in standard form, that's going to be 1.4 times 10 to the 13. Okay, so if you'd written times 10 to the 25 or times 10 to the 24, then you have not read the question properly, or you have a misunderstanding of how to do addition. Hopefully it's the former. We really have to understand this question. The reason this question is put in first is because it allows us to do the algebraic stuff later. Notice how 14 is bigger than 10. So to get from 14 to 1.4, I've divided that by 10. And because I've divided that by 10, the power increased by 1. Notice how in this new algebraic question, we have effectively the same thing. 9 plus 5 was bigger than 10, p plus q is bigger than 10. So since p plus q is bigger than 10, that means we're going to shift over to a new column, which means where we had powers of 15 before, we're now going to have the power go up by 1 for the same reason it went up by 1 in question 6a. For r, 14 didn't stay as 14, 9 plus 5 didn't stay as 14, it became 9 plus 5 divided by 10. So r, that number in standard form, is going to be p plus q divided by 10. Now check that this makes sense with 6a. 5 plus 9 is 14 divided by 10 is 1.4, which is what r would be. And the power in question 6a is 12, and the power for the answer is 13, so it's gone up by 1. So it all makes sense, it all fits with the question we did in 6a. So the key information was what I've underlined there. P plus q is bigger than 10. If p plus q is bigger than 10, then the number wouldn't be in standard form, so I have to change it so it is. Okay, moving on. This is a non-right angle trigonometry question. The first question really relies on you picking the right triangle. So the triangle we're going to start with is the sine rule, but with triangle ABD. Okay, you could label this triangle if it's helpful. For me, with the sine rule, I know that opposite sides map to opposite angles. So I can say that side BD divided by sine of 115 is the same as side 5.8, or is it 5.5, sorry, divided by sine is 5.8. So I've just correct that. Okay, so we have 5.8 divided by sine of 35. And so opposite sides map with opposite angles. From here we simplify, we're trying to make BD the subject, so we times both sides by sine 115. We could then rewrite this as one fraction if we wanted to. We don't have to. We could just type that in our calculator. I should probably put brackets around all of these angles. When we put that in our calculator, we get 9.16 to 3 significant figures. Okay, so we know that BD is 9.16. I'll put a ... there to signal to the examiner or the reader that I've rounded it. I shouldn't just use 9.16, I should use the actual answer, and you can do shift store in your calculator to get that answer. From here, calculate the area of triangle BCD. It's not a right angle triangle, so we're going to have to use the area sine rule, which is a half AB sine C. For me, I don't relabel when I have this. I know that this A and B are adjacent sides to an angle. So with that angle 52 degrees, I have the adjacent sides 13.5 and 9.16. So I'm going to use those values. If it's helpful to relabel, then do. But I'm just going to say that this is a half times 13.5 times that 9.16 dot 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 times by sine of 52. When I plug that in, I get an answer of 48.7 to 3 significant figures. Okay, so that was that question. Moving on. Probability tree diagram. You have your first event, which is picking from the bag. You can either pick red or yellow. And then the second event, you can either pick red or yellow. Then you write the probabilities on the tree diagram. There are 7 out of 10 red counters. If you pick one of those red counters, then there are only 9 counters left. 6 of them are red. 3 counters left are yellow out of a possible 9. Similarly, 3 out of 10 are yellow, and then 7 out of 9 are left if you've picked a yellow, and 2 out of 9 there. So in the second question for B, it asks you to write the probability, or find the probability that he picks one of each colour. This is the probability of going down the branch red then yellow, plus the probability of going down the branch yellow then red. We multiply along branches, so we've got 7 out of 10 times by 3 over 9, plus 3 over 10 times by 7 over 9. When we do the multiplication, we get 21 over 90 for each of those probabilities. Adding them up gives 42 over 90, which you can write. Alternatively, you can simplify, giving you 7 over 15. Moving on. This question, it was important to underline the information so that you didn't ignore that it was the square of the distance, for example, and inversely proportional. So we know that inversely proportional means we can say that f is proportional to 1 over d squared, the distance squared, which means the algebraic relationship is k over d squared. Now notice in this first part, we're not given any values of f and d. We can't find k, so we leave it in. Okay, it doesn't ask for the formula for f in terms of d. It just says write down the algebraic relationship, and there it is. In the second question, we are given some information, so we can substitute these values in to find k. We know that d is 900, and we know that f is 500. We substitute those values into the formula we've just written, giving us that k is 500 times 900 squared, which is 405, I think that's 405 million. Nice. So what I'll do now is I'll rewrite my formula with k in as 405 million. Okay. In fact, what I'll do is I'll write down the next step. We could have written d squared, but I'm thinking ahead and I'm going to put 902 squared into this formula. The reason I'm putting 902 squared into this formula is because if you read really carefully in this question, it says that d is from the center of the planet. And it says that 2 kilometers above the surface. So the value for d is the whole radius, 900, plus the 2 kilometers away from the surface. So it's 902, not just 2. Okay, so that was a common error to misread that really subtle point. If you substitute that in, you get f is 405 million divided by 902 squared, giving you 497.7 stuff. So to 3 significant figures is 498 newtons. And that was the answer to this question. Another non-right-angled trigonometry question. This time it's a show that, and we should know how to do show that questions by now. Show that question means our final line is what they want us to show. So our final line should be AC equals 16. That's what it should be, and nothing else. And you work down the page, and that's your final line. You start from what you know, and what you know is that the area is 40. But what is the area? The area being 40 is a half AB sine C. In this case, it's a half 10 times B times sine of 150. Remember, it's adjacent sides times by the angle between them. Okay? So we can replace the values that we know into this formula. Okay, the one we don't know is b. So we only have one unknown, so we can start to manipulate this equation. Half times 10 is 5, times b times sine 150. And when you do sine 150 in your calculator, you get a half. Okay, so we could divide both sides by 5, giving us 8 times a half b. And then times both sides by 2, giving us b is 16, as required. That's what we wanted to show. We wanted to show that that side, AC, was 16, and we've done it. The next part asks you to find the length of BC. Since you now have two sides, an angle, and you're trying to find a missing side, it's probably best to use the cosine rule. And in fact, we can only really use the cosine rule to do this. So a squared plus b squared, a squared equals b squared plus c squared minus 2bc cos a. We substitute these values in to give us this. We put these in our calculator, and we get 356 minus 320 cos 150. This gives us 356 plus 277 point something, and this is our value for a squared, which ends up being 633 point something. So this means that a is the square root of 633 point stuff, which is 25.16 to 2 decimal places. Now you probably didn't need to write all these lines. This line, and the final line obviously would have been sufficient. Writing more lines, if you did make a mistake, the examiner would see what stage you made the mistake in. So that should have been the solution to that one. Next, moving on. The first three terms of this arithmetic series are 2, 5, 8. It's just linear, it's like the 3 times table, but it's shifted down by 1. Using more algebraic techniques, we know that the nth term, or un, which we tend to call the nth term, is the first term plus n minus 1 lots of the difference. The first term is 2, the difference is 3. If we simplify this, we get the same thing. Okay, so it works both ways, either just spotting it using simple methods or using a more algebraic approach. Evaluating the first 100 terms, S of 100 is going to be this formula, substituting n to be 100, a to be 2, and n and d to be 3. When you substitute all this in, you get 50 times by 4 plus 99 times 3, which is 50 times 301, which gives you 15,050. Okay. Moving on. I'm going to show you a really algebraic approach to question 12. Okay, so we have the 50th term, which we know to be a plus 49 lots of the difference. We're told in the question that the 50th term is 70. Okay, so we can state this equation. The first term plus 49 differences is 70. For the 20th term, this is the first term plus 19 differences, and this gives us 10, because that's what we're told in the question. Notice how we have a simultaneous equation now. We have two unknowns, two linear simultaneous equations. If we take the difference between the two equations, we're left with 30d equals 60, giving us d is 2. To find a, we substitute the value of d into, say, the second equation. So a plus 19 times 2 is 10. A plus 38 then is 10, so a is negative 28. So that's our first term and our difference with a more algebraic approach. To show that the sum is 0, we need to have s of 29 to be 0 as our final line, because it's a show that question. S of 29 is 29 over 2 times by 2 lots of the first term, minus 28, plus 29 minus 1 lots of the difference. Now, if you substituted your numbers in, I gave you a mark, but if you did substitute your numbers in and you didn't get 0, it's probably because, or you should have realised at that stage, that one of your answers, A or D, was wrong. So if you do substitute these numbers in correctly, you get 50 minus 56 plus 56 in the brackets, which obviously gives you 0 as required. So any show that question as required is a really nice way to finish it. The final question then. We'll start with the easy statement, the 20th term. So U20, the 20th term, is a plus 19 differences. Okay, so this is a really algebraic approach. For the 10th term, we know it's a plus 9d. And we know that this is, we know it's 2 lots of the 4th term. So let me just change that to be 2. Okay. So we know that the 10th term is 2 lots of the 4th term. So a plus 9d then is 2 lots of, so I'll change that again, a plus 3d. Okay, so a plus 9d is 2 lots of the 4th term, a plus 3d. If we expand the brackets, then we get 2a plus 6d there. And continuing, we can subtract 6d from both sides to give us 3d, and subtract a from both sides to give us a on the right-hand side. So I subtracted a from both sides and 6d from both sides. So I know a relationship between a and 3d now. What I'm going to do with this relationship is substitute a equals 3d into my expression, or my equation, for the 20th term. This means that 3d plus 19d is 44. So I've replaced a by 3d in that equation at the top of the page. 3d plus 19d is 22d, which is 44, giving me the difference to be 2. Since we know the difference is 2, and we know that a is 3 lots of d, we can say that a is 3 lots of 2, which is 6. So that was an algebraic approach to solving the final question from the test.